Hello, everyone. My name's Brian Meadows. I'm the Executive Director of the Center for Future Innovators, CFI Robotics NFP, and I'm glad to welcome you to today's webinar. I want to thank you for spending part of your day with us. Thank you for joining us this evening. I know it's winding down the end of summer and that some students are getting ready to go back to school already, but thank you for taking this time out of your busy schedules to be with us today. I'm really excited for what the students have in store. At the Center for Future Innovators, we believe every student deserves the opportunity to explore boldly, think critically, and grow through hands-on STEAM learning, science, technology, engineering, arts, math. Our programs in robotics, coding, science, and leadership are all built to spark curiosity and help students develop skills that they're going to need in this very fast-changing world. We offer after school programs, summer camps, weekend workshops, online programs, international exchanges, and many different things. But no matter what format your experience with CFI is, our goal remains the same. It's to inspire the next generation of innovators and global thinkers. We're very proud of the community we've built, one that values curiosity. It embraces diversity and celebrates our students and their hard work. And it makes spaces for every student to find their spark, their interest, their passion. Events like today's webinar are part of this mission. It's a chance for students to show not just what they've learned, but to introduce it to other students, to say, this is something you could learn. What's possible for you to explore through your interests and connect other students with their own passion. Hopefully that inspires you to have a passion in the science field as well. I know I would not have gone into STEM if I didn't have, well, I had a crazy physics professor that looked like Santa Claus that made me love math and physics. And that's why I got into STEM. So these sort of events, these can really change a student's life. And we're very grateful that you're joining us for this deep dive into the world of science today. Now, before we begin, I want to thank our host, Tim, and our speakers today, Dylan and Ian. They're both shining examples of what's possible when students take initiative, embrace learning, and share what they've discovered with others. They have a roadmap of how they've got here that's intense. Their dedication to chemistry is phenomenal. And I'm really happy that they're going to be able to share those journeys today and hopefully inspire some students to make a similar journey. They're perfect role models for an excellent student in STEAM. But thank you so much again for joining us. Tim, are you ready for me to hand it over, or I can talk more about CFI? That's what I do all day.
No, I'm all good. Thank you so much, Mr. Brian, for going over with that. Yeah, thank you for that wonderful introduction. As most of you guys know, my name is Tim He, and I'm a co-founder here at CFI and the vice chair of the board as well. And we hosting many of our online segments and be teaching some of our classes and specifically coaching our middle school robotics teams. I'm so happy to be here today with two wonderful new graduates from the Illinois Mathematics and Science Academy who are going off to studying some amazing things this fall, very, very, very soon. And of course, we have Dylan and we have Ian. Dylan, would you please introduce yourself?
Of course. Thank you for having us, Mr. Tim. Um, as you probably know, my name is Dylan Xianto. I'm currently a rising freshman at the University of Illinois Urbana-Champaign, and I intend to major in chemistry. I've had 4 years of experience with the subject, both at IMSA and before joining the school, and I'm excited to speak with you all today.
Thank you so much, Dylan. And Ian?
Hi, I'm Ian, so I'm also going to UAC similar to Dylan, and I'm majoring in environmental engineering. So not specifically chemistry, but there is a lot of chemistry in it. But yeah.
That's awesome. So both of you studying at IMSA and now actually both going to U of I. What is something that you guys are really looking forward to now that you're going to be in college?
Okay.
At university, it's just going to be very interesting, not just getting into a community with a lot of other peers with similar scientific experiences, but there's also just so many other opportunities to both further one study in the subject as well. It's going to be very interesting.
Yeah, I'm also pretty excited to kind of like be able to get deeper into an area of interest because obviously high school doesn't really offer that. So that's definitely something I want to do more at college.
Definitely, definitely. And okay, so everyone, this is the general pathway that we'll talk a little bit more about in a second. But as you can see here, it is a traditional pathway for how most students take chemistry. Give me 1 second. I need to let my dog out because he is being a cute little stubborn butthead. 1 second.
This is our typical pathway from curiosity about any sort of science, but specifically here, chemistry, into getting into that competition level. So Tim's going to go over it with us a little bit more once he's back from his dog. Thank you so much, Mr. Tim. Welcome back. The reins are yours.
Yeah, sorry. We'll go into this into a little more detail after we talk a little bit more with Ian and Dylan about their own experiences, and then I'm just gonna stop sharing right now so we can get a easier look and communicate a little bit better. There we go. Perfect. Ooh. So I think I have a fun little question for us to start off today. Since we're talking about chemistry, do either of you, or Dylan or Ian, do you have a favorite element on the periodic table?
Oh, this is good. This is a tough question.
You want to go first, Dylan, or I can talk a little?
Oh, why don't you go ahead? Yeah, yeah.
Okay, I have a maybe a little boring answer, but I'd say carbon is probably my favorite, just because like it's super obviously widespread. It's really important for all of life. And also, I guess in high school, most recently I've been doing organic chemistry, and I think drawing the diagrams with the carbon chains is pretty fun.
That's
Definitely.
awesome. Yeah, I didn't think about that, the last part of the diagram part, but yeah, I mean, we all think about carbon and know carbon as the most abundant and the building blocks for everything else that we have in life. But yeah, that's cool. Carbon makes sense. What about you, Dylan?
I was thinking about nitrogen actually. It even though it's one of the most important elements for not for plant growth and our growth as well. And it's interesting that despite the fact that it makes up 70% of the Earth's atmosphere, it's very abundant here, that it's kind of hard to actually make usable. So I just find this element very interesting.
Interesting.
Very cool. Yeah, I didn't realize that part about nitrogen, and I'm sure you guys know so much more about these things than I do. But uh, there are so many fun facts and interesting things about chemistry and ways that I think that it connects with just so many of the stuff that we do in our own lives that we don't think about. That I truly believe it is one of the sciences that may seem scary to some of our younger students, but once you get into it, and I'm sure Dylan or Ian can talk more about it later, it's quite fun. All right.
Yeah.
So specifically, Ian, why do you think chemistry is cool or important?
Really for me, uh, for a lot of these STEM fields in general, but definitely chemistry, I think I guess the best part of it is how so many things are based on these kind of scientific concepts, like especially in the natural sciences, a lot of the processes you see, like in the environment, around you, even like in your household, these things are all kind of based on chemistry, and kind of being able to learn about that and kind of understand why these things are happening and how they work is pretty cool for me, definitely.
Mm. And Dylan, are there like things that you can think of that off the top of your head that is something the chemistry related that is around us that we typically don't think about?
Well, the first thing that comes to my mind, again, let's go back to nitrogen, how it's so abundant in the atmosphere, yet in the environment around us, yet we can't, yet in its inert gas form, we can't use it at all. Something interesting is that actually the reason why half of the current 7 billion people on the world are alive is due to probably a single chemical reaction. It's the Haber-Bosch reaction. It's the synthesis of ammonia from nitrogen gas and hydrogen gas. But because we're able to produce ammonia on such a massive scale, we're able to make this nitrogen more available, for example, to plants, which uh, which made a chemical fert which whose chemical fertilizers essentially made food out of thin air. It's a very interesting subject.
Absolutely. And you learn that so many things are connected in different ways, and that balance that we learn in chemistry is something that we have in the rest of the world and what keeps us all alive. Um, so if have either of you ever had a chemistry experiment where either the outcome was something very, very unexpected, or just completely wrong? And how did you guys work with that? What did you guys do?
I
Would you like
can
to?
I can go ahead. Yeah. So, I mean, for me personally, it's hard even to pinpoint like a specific experiment that I recall because, especially like in a research setting where I've is probably where most of my experience comes from. The nature of a lot of the experiments that you do is that they're kind of designed to go wrong, and they usually will go wrong almost all the time. And the most important part of that is knowing the chemistry behind it and kind of being able to use that to kind of figure out what went wrong and kind of address that, fix any gaps in your knowledge. It's not really about just being able to know and predict everything that's going to happen, but rather apply that knowledge to things that you don't know to try to understand more. So, I mean, this has definitely happened a lot of times, but I think it's even normal for experiments to have this kind of outcome.
And yes, what Ian said is completely correct. Really, the most important thing to do in the sciences is just if you do have a result, just make sure that once you repeat the trial, that you have to make sure you have to change. It's a good idea to take a look at what you did, change something so that you don't just keep repeating. You might find some progress that way. If I may go off on a bit of an anecdote related to this, um, I've performed some pharmaceutical research when I was a junior at IMSA, and and especially when you're applying the science to these larger topics, you're always going to run into problems. For instance, I had a particular problem. My project was delayed for a few weeks because I couldn't seem to just combine two molecules together effectively enough. But over time, with taking a look at different methods to synthesize the final medicine, uh, it did work. It did work eventually, and we were able to make something out of those 2 weeks of delayed progress.
And I think the two of you bring up really good points in that success looks very different for the different things that you have to do. It does like not everything is a black and white. Hey, I did it, and hey, I failed. You learn so much from your so-called failures, and the that's just part of life, and that's just what you have to do. So I think this is really good encouragement for a lot of our middle schoolers who are dealing with so much right now, and might get a little discouraged from some of the more difficult things that they're tackling right now. Yes, you will have to deal with those no matter what, but it's how you look at them, and it's what you do afterwards that really make the difference. So going into, I think, Dylan, you talked a little bit about your experience in high school and then getting an internship, but how did we all get started becoming interested in chemistry?
Well, getting interested in chemistry is kind of from my personal experience, it's a bit of a longer process. It I mean, especially since it can be quite the topics can be quite tough sometimes. Um, and I've just personally found that once you start getting hold on some of the principles, then and start building up a sort of foundation, you slowly get to appreciate not just subject, but also the world around you eventually.
I can totally see that. What do you think, Ian? Like, um, did you have an interest in chemistry before you even like took your first chemistry class in high school or middle school?
I think for me, I guess at the very beginning, really, I started with chemistry just because I guess I didn't really take a liking to the other main fields like biology or physics. But eventually, like once I started kind of going through high school, realizing my interest there in like natural sciences and environmental science, chemistry started to appeal to me a lot more just because it's really like the backbone a lot of those processes that you need to kind of study and understand. So, because of that, chemistry was pretty interesting, and I really enjoyed learning about how those things work, pretty much.
Hmm. Yeah, and for all of our middle schoolers listening in, those big three general science classes, biology, chemistry, physics, you can't escape them. Mo Part of that will connect to no matter like what kind of field you're doing in the future. Those three basic core science classes, I think, are essential for everyone who wants to go into the professional world, whether it's in STEM or not. I think some of those are the core classes that really teach you so much about life and the world around us. All right. We touched a little bit on what a roadmap might look like in when we're studying chemistry, and we're gonna go back to that one. Give me 1 second to pull it up. To talk first about this traditional roadmap. Now, for most students on today, I'm assuming that we are going to public school. Uh, Generally speaking, for middle school students, you're taking just the general science, middle school science classes in middle school. I know some schools also might have you take like a high school science elective in grade 7, and then like a honors biology in grade 8. But generally speaking, yeah, this is what we have for a lot of different students, and this is the basic one that a lot of students have been using in the past. Whereas once we get into grade 9, you're taking honors chemistry. Grade 10, if you still have that interest, you would take AP chemistry, and then after that would be prepping for the USNCO, the Chemistry Olympiad program, and taking those tests in grades 11, most likely grades 11 and 12, depending on your own availability. But before we get into that, can either Ian or Dylan, can you guys talk a little bit about what USNCO is?
Uh, of course. So the United it stands for the United States National Chemistry Olympiad. It's a competition that selects that will eventually select the students who will represent the United States at the International Chemistry Olympiad. And would you like me to go a bit into the structure of the competition?
I think if you or Ian, if you want to take over from that section, or either way is fine.
Yes, so content-wise, essentially you could think of USNCO as kind of the level above the AP, I guess, kind of chemistry. So it kind of goes into more depth on the kind of AP topics and also covers some new topics that I guess are harder and maybe more unfamiliar to most people. As far as structure, I think Dylan would probably have more information on that.
Got it.
Yes. So the USNCO is actually two tests, really. The first is a locals level exam, which is grouped based on the geographical section in which you go to school in. For instance, um, Ian and I took the USNCO under the Chicago section because IMSA, where IMSA is located, it's contained within there.
Mm.
After this local exams, there are only two people, at most two people per school, who can go on to the next national levels. And here at the national levels, instead of being a traditional paper test like the locals exam, there are multiple sections, a multiple choice, a laboratory section, and a short answer
Mm.
section. And then based on your scores in these three sections, the committee chooses the top, say, I believe 20 or so to participate in a study camp for the International Chemistry Olympiad. And then of those 20 students, I believe four of them, the top four, are chosen to represent the United States.
I see. Wow. So for those who haven't heard about this program, the Olympiad competition program exists for most of the big STEM fields, like in math and computer science, in physics. The math one is probably the most popular, and as well as the computer science as the most well known. But chemistry and physics are getting more and more popular and starting to be more and more competitive as well. But this is the most, or I would say it's probably the most competitive and highest level of chemistry competition available for high school students. I don't know if what Dylan and Ian, would you agree with that?
Yeah, I agree.
Yes.
Mhm. So students who do excel in these programs, often if they don't, end up in chemistry, these are students who are already going to excel no matter where they're going to be. But it's that I think we'll talk a little bit more is that work ethic that you develop learning through it, and that curiosity that you must have to help you drive through all of this material and information. Um, Now, I know for Ian, your experience is a little bit different, and so is Dylan, because you guys were at IMSA. So, at IMSA, what was your pathway like as a 10th, 11th, and 12th grade student?
Yeah, so if you guys aren't familiar, essentially it's a 3-year boarding school, boarding high school, so it doesn't have a freshman class. So I guess my pathway is probably a little bit different because I went to IMSA straight from 8th grade. So I skipped my freshman year and I didn't like do ninth grade at all. So at IMSA, I started 10th grade in just the basic introductory chemistry class. And in that same year, I enjoyed chemistry and I wanted to do some kind of AP exam. So I self-studied AP chemistry during that same year, but like kind of in the later portion. So after I was done with the introductory class, and then after that, into my junior and senior years, I focused more on studying for the USNCO.
So, Ian,
Um,
quick one. I have a quick question for you.
yeah.
So, would you say that introductory class basically prepared you, at least the content wise, you were prepared for the AP exam, but maybe not the format?
Yeah, so obviously like your class is gonna have different kind of questions than the AP test, but obviously this is just it's introducing the fundamental principles that pretty much everything else is going to be working on. So yeah, I mean definitely the introductory class is useful.
Hmm. Yeah, and
And
then
then
for other students, that introductory class at IMSA is going to be comparable to what AP chemistry is at other public schools.
yeah, so in addition to like USNCO prep in my junior and senior years, IMSA also has like a variety of other chemistry courses. So I took things like biochemistry, organic chemistry, and physical chemistry. So those are not all necessarily applicable to the USNCO, but they are other things that IMSA offered and other parts of chemistry that I learned about as well.
That's really awesome. And I think, I mean, most people would be really jealous because a lot of schools, of course, they just offer the basic chemistry, honors chemistry, AP chemistry, and that's kind of it. So, I mean, that's why we want to have this kind of program to be able to help other students who have this interest be able to really pursue that. And what about you, Dylan? I know as a now a chemistry major, what were some of the other things or classes that you took at IMSA that were chemistry related?
For the most part, my my uh my educational journey in chemistry is somewhat similar to Ian. I took honors chemistry as a ninth grader, and and uh, and began with actually environmental chemistry as a 10th grader. And then from there, I took the pretty much all the other advanced chemistry courses at IMSA between then and the 11th grade. The same ones that Ian was talking about. So biochemistry, organic chemistry, physical chemistry.
And then the one that you added, I'm sorry, what was the one that you said you also took?
Oh, environmental chemistry.
Environmental
Yeah,
chemistry. And
so
then
that's kind of like that was the placement for like if you already knew like the introductory stuff in sophomore year.
I see. That makes sense. So IMSA as a school offers five chemistry classes with
Yeah.
introduction to chemistry, which I think is very cool. But unfortunately, for most students and your schools will not offer those classes. So you will need to do a lot of self-studying or join similar programs to ours in the future. Or, honestly, for most of these students, they were able to do it partially through their school, partially through self-study, right? Give me 1 second. There. Ah, my computer's being silly. All right. So this is the general program the pathway that we were just talking about. And then the pathway that we want to introduce a little bit more is having students be able to, just like what Ian and Dylan were saying, be introduced to chemistry at an earlier point and be able to start preparing for that Olympiad competition slightly earlier as well. And that requires being able to either take chemistry, honors chemistry in that middle school area, and then in ninth grade being able to take AP chemistry and then moving on. Of course, for a lot of students, your school might not even allow you to take AP chemistry as a freshman. But of course, you can always prepare for that class yourself. And you can even, as a middle schooler, if you're ready for it, to prepare and take the AP chemistry test. As long as your neighborhood public school offers that test, you can petition to take it as well. So these are all things that are possible for students, but it does take a lot of preparation for you to for people to get there. All right. So, Dylan, do you have any recommendations for what middle school students can do right now if they have an interest in the sciences?
Um, what you can do now, especially outside of school, I'd suggest that you can get an introductory field for some of these sciences. There's a lot of freely available resources, say at the local library or online on the internet that you can sort of skim over, just slowly acclimate yourself to. And then so when you actually get formal education in these sciences, then the journey can become a lot faster for you.
Absolutely. The fact of previewing that material first and having to learn it again really helps reinforce all of it, and allows you to think a little deeper into the material there too. Um, what about you, Ian? Were there anything that you did in during middle school that you would recommend for others?
I mean, not necessarily things that I did specifically. I mean, obviously, I'd recommend just exploring as much as you can in middle school while you're not really pressured so much to focus on one specific thing yet. Like, just exploring different areas of STEM, trying to learn multiple things to see what you're interested in. Really, in middle school, before this high school stage, I would try to kind of figure out something that, if possible, try to figure out something that you really enjoy learning about, and then something that you can kind of take into high school and kind of develop that further and really like develop your skills in that specific area.
Got it. So, as you guys now, once you guys were in high school, after you were taking your essentially the AP chemistry for you guys, um, and started preparing for the USNCO, what did your study routine look like? So either Ian or Dylan.
For the USNCO, a lot of the topics within are not really covered in the courses that you'd see at school. For instance, there's a sections on inorganic chemistry which aren't offered. So I
I'm
ended
sorry,
up I
sorry.
ended
Quick,
up
quick
setting
pause. What is inorganic chemistry?
for a bit of clarification, inorganic chemistry is it's it's a very wide a topic that deals with molecules that aren't necessarily carbon-based, while organic chemistry primarily takes care of carbon-based chemistry.
Makes sense. Thank you so much.
And to study some of the subjects like this, I ended up having to section off maybe an hour or two every day during the school year after school just deal with these topics on a deeper level.
Oh, and Ian, would you agree with that about
Yeah,
it?
definitely. I mean, I think that, I mean, one of the most important, if not the most important things when you're trying to prepare for any of these kind of like out of school kind of Olympiad style exams is that you really need to establish a routine for when you want to like take time to kind of study for this because just your normal school courses are likely not going to teach you enough, especially at the younger stages or earlier stages when you might want to even start preparing for this. So definitely just establishing a routine and making sure that you have a kind of a schedule that you know what you need to be learning and when. I would definitely recommend planning that out, just to make sure that you're able to learn everything and be successful.
Yeah, it sounds like there are quite a lot of material that is basically expected that you learn yourself. Does the UNSCO provide a study guide or like materials that will be covered on the exam and everything that way?
Okay. So the American Chemical Society is the organization that carries out the USNCO. They do have a website that provides. They don't provide study guides per se, but they do provide an archive of all of the historical exams. I
Mm,
believe up to the early like 90s, I believe. And it's probably the very best resource that you want to use if you are planning on performing well on this exam.
Yeah, I definitely agree. Like the practice tests are something you should really be doing on a at regular intervals, and then it's probably one of the best ways to prepare as well.
Hmm. So it sounds like really keeping that schedule and a timeline for yourself is key no matter what we're doing. Do you have any tips on how you were able to manage your own times? Like for me, I need to have an alarm set on my phone to be able to do it for myself now. How did you two manage your times while you're preparing for these intensive competitions?
Yeah, I feel like this is kind of like a general tip for high school, like overall, like managing your responsibilities and knowing when you need to get things done is very important, even like throughout life and past even your high school or college. For me, I really benefited from making to-do lists and also just using like calendars apps like Google Calendar just to establish like regular events or blocks of time where I know I'm supposed to be doing a certain thing. And to-do lists also just to keep track of everything I need to get done so I can also schedule those things. But yeah, I mean, this also applies to like any other thing that you might need to prepare for or do on a regular basis, but definitely like using calendars, using to-do lists, that'll help you kind of enforce that kind of schedule.
I agree. And are you a physical to-do list or on the phone to-do list?
I usually just do it online on my computer. Physical is kind of it's just too much hassle, really,
I get it. I get
especially nowadays. Yeah.
Yeah. I still enjoy having a physical list for most of my stuff. Sometimes for my like big calendar stuff, that's all on my phone. But I so
Mm.
like having like a list that I can write down and cross
Yeah,
out.
it is definitely useful. Um, I guess it's might be more convenient, especially when your teachers don't want you to use electronics in class, which is something I've dealt with before. Even if you're doing something productive, they might just not let you do it. But yeah, I
That's a
mean, I
great
think
point.
both
I
are
totally
fine.
forgot about that.
I mean, it really depends on what you prefer. I think both work pretty well, as long as you're able to kind of remember that stuff.
Makes sense. What about you, Dylan? Do you do anything differently?
Uh, somewhat. I most of the time for the times I set aside for the studying the USNCO, I just made sure that I built up a habit. I kept a designated time.
Hmm.
I kept a designated schedule. So immediately after, say, a class, then I would try to go to a specific place within the library or within a study area, and then and then do the studying for a few hours until I would get dinner, and then that would be it. Another important point actually is that it's also a good idea to take opportunities, time-based opportunities when they occur. For instance, if in some day a class gets canceled or you suddenly have an unexpected break, you have a meeting that got canceled, you can use that free time in order and just do a bit of reading on your own. Just like set yourself up for the uh next session, and
Y'all,
then it,
that
it
is
really helps if you're interested in the subject.
I
That tends to
totally
help.
agree with you, Dylan. And that's honestly the best way to do it, especially when you have so much material you need to get through. So our high school and middle schoolers now, if you're listening to this, it really depends on what you want, right? If you have these goals and you have these things that you want to do in the future, like Ian does and like Dylan does, the you need to prepare yourself. You need to make sure you're making time to put in the effort. Nothing comes easily, right? We need to put in that effort to be able to get the results that we want. You hear from both Dylan and Ian how much they've put towards just one subject that they're studying towards. This is not the only thing they've done in high school, right? They both of them have done other similar level things in other fields as well. So these are just stuff that if you want to be successful, if you want to be the best of the best, if you want to really see what change you can make in the future, these are the habits that you guys need to pick up now. So that once you're in high school, it's a little easier. You already have that habit built, and that you can be just as successful as these two wonderful speakers as we have today. So in talking about a little bit about chemistry in itself and what we can do, what do you guys think, or how do you think chemistry is important in solving some of the global challenges that we have? Like, what can chemistry do for us in the future?
I mean, I feel like I can
Oh,
definitely speak on this to quite an extent because um, obviously I'm not specifically in chemistry, but more of an application, which is environmental science, specifically environmental engineering for me. And I think like this kind of thing gets revealed a lot more in like if you're able to do some sort of research or research internship in high school. So kind of doing work with a real lab. So a lot of some things I've done that are very chemistry focused are things like kind of studying ways to do carbon capture. So for things like that, it's important to know about ocean acidification, how carbon dioxide will interact with water to create acid, and also just like how it interacts with water and air in general. There's also things like water quality. So I've done projects on like water treatment. So a lot of like the water treatment process you might not be familiar with at all. You might not even be really aware of the what like how water treatment is going on in general, but all of those processes that are kind of working to just serve the public and that no one really thinks about, those are all kind of powered by chemistry and those chemical concepts and those processes. So I think the point of learning this, at least in this introductory stage, which is high school before you go into college and your career, is getting that knowledge to be able to kind of understand these processes so that in the future you can kind of work to be able to improve them, develop new ones, and kind of solve these problems that are, I guess, intrinsically related to chemistry that people have a demand for, pretty much.
Yeah, and I think you bring up a lot of great points, Ian. Like, it's just the knowledge that you have from studying chemistry is implied in so many different places, and especially in the STEM fields, that is just so important for everybody to have that understanding of it, to know how it works, because you never know where your career will take you. Um, what about you, Dylan? Where are you thinking about how chemistry is relating to our the challenges that we face?
well, if you break down the subject of chemistry to its very most basic form, it is just the study of matter on a useful scale for for humans. Every since we are just material beings on this earth, and there are what, tens of thousands of issues, whether it is diseases such as leishmaniasis or or products such as, you know, batteries or electronics. Each one of these has a root in chemistry. And so if you were to apply this subject, then applying chemistry is like getting the tools to solve these worldly problems. That's how I would put it.
Absolutely. Yeah, I totally agree with chemistry, and that's honestly why these courses and basic chemistry is one of the courses that's required for almost all students, because there are parts of it that are just so essential to life and to learning more about what it is, right? And of course, we always say math, you have to have your math first, and then if you are interested in the chemistry side, chemistry. If you're interested more in the life sciences side, you can go into biology. If you want some more math, we can go into physics. Um, but yeah, there's just so many, I think, interesting ways that a lot of these sciences intersect. And both of you have brought such great points into that as well. Um, I know we're cutting it close for the general part of our talk for today. So if any of our participants, if you guys have any questions, please type them into the chat, and then we'll slowly starting to have Miss Lee help us go through the questions in the chat as well. Um, so one of the things that I am very, very excited to announce is that CFI will be piloting our new chemistry, online chemistry program this fall with honors chemistry, AP chemistry, and then the UNSCO competition prep with Mr. Dylan and Mr. Ian here today. As we've seen in the previous slide, so this is what my new goal is, and for almost all of our students and for the future students as well. I want us to be able to help starting the students who are interested in chemistry, be able to support them and have them and offer those programs in middle school so that they can get started earlier on the AP chemistry and then the USNCO prep while they're in high school. So much of the material, like Dylan and Ian said, had to be self-studied because a lot of that information or just curriculum isn't available. With their experience, both of them have helped write new curriculums for honors chemistry going into that AP chemistry and then the chemistry Olympiad preparation as well, based off of what they know, based off of their experiences with the test, and based off of the past tests as well. So I'm really, really happy that they're willing to give back to our community in this way, and we'll have more information about those in the coming weeks. So very, 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 very soon. All right. Let me see if I can find our first question.
We do have a question in the chat. If anyone has more questions, feel free type it out or just open your mic to ask questions.
Oh,
Thank you so much.
let me turn on microphone. I think I turned it off.
No, they can raise up their hand and then they can turn it on.
Oh, sure.
Any questions?
No question.
So I have a quick question actually for Dylan and Ian. How hard actually this competition is, general speaking?
All right. Miss Lee, could you please elaborate on what you mean by how far exactly?
No, sorry. I mean, how hard it is. Like, I don't know if you guys, because I'm not familiar with the chemistry area. You know, I do help a lot of students prepare for the AMC. I don't teach, but I observe those questions. So compared to like USACO, you know, computer science, you know, Olympiad competition, compared to AMC 10 and 12. So is that kind of the same level for the chemistry as well?
Well, if we're talking about comparisons with other Olympiads like Math or Computer Science, I don't think we could adequately give comparisons, kind of like comparing apples and oranges, so to
Yeah.
speak.
I don't think it's really useful to compare across fields. But I guess USNCO is usually like at the level or at a further level than a lot of your, I guess, the high school classes or even IMSA's classes. So at a more traditional high school, it'll probably be like much above that level, if you can think about it that way. So it'll
To elaborate, a lot of the principles you see on the USNCO will be covered typically within the undergraduate years of education. If I would like to provide a bit of insight on the difficulty of the USNCO, I mean, compared to other subjects, I'd say that every subject has its own different intricacies, really. Some are more theoretical, like the math. Others require a lot of visualization, like in chemistry.
Got it.
So it's really up to the individual person and their like aptitudes toward learning that will determine how hard it is, really.
I see what you because I think there are some other, like for instance, computer science is a little bit easier to quantify comparatively, just because, I hear a lot of professionals say like if they had taken the test, they could only get like a certain point, which is very different than what the chemistry the part is. Because theirs is much more is they have to answer something and make it work. This is very different from what they have there. But from what I'm getting at is it's comparable to the other Olympiad competitions in its difficulty in regards to its field.
I guess. Thank you so much, guys. But yeah, I overheard some of the parents talk about it. They think the Olympiad competition for biology and the chemistry is a little bit content related more than like the USACO or math. For math, if you know the math, that doesn't mean you can problem solving that question right on site. But for chemistry, if you really know your content, you don't need a lot of problem solving kind of question. I don't know if it's right, but so to my understanding, so I will really encourage you who think you are good on study, you have the passion for chemistry like you guys, for biology, and you are hardworking. So there might be a slightly chance. So so call me wrong, but there is a slightly chance you can be I don't know a better result when you enter the competition. Can I see that way? I'm sorry to be such a practical way to think about competition, because it's hard. Every kid has so many things. So as a parent standpoint, as a principal, I do want my students kind of able to get some award after they working so hard in some area.
So that Miss Lee is speaking as her position as principal as Pagey. That is not our position as CFI teachers.
I guess like, are you asking like, is the, I guess you could say problem solving skills from like, I guess from math able to be carried over to this,
I
or
think it's more so when you guys are doing the competition, are is there more problem solving, or is there more like you have to understand the content and you'll be able to answer the question? Because for like the math Olympiad and for computer science, a lot of that is just pure problem solving.
I would say that it's somewhere in between knowing all of the content and problem solving.
yeah, I
Mm,
mean,
Because for chemistry, you're going to need to know a base set of knowledge, a base knowledge in order to do the problems in the first place. But they're not going to be as straightforward as, say, in biology, where memorizing a lot of the components can get you very far. You have to be able to apply it like uh, like in math.
yeah, I'd also say like there's both in any like in a lot of the main like science fields that you think of like biology, chemistry, physics, there is a memorization involved, obviously, just because you need to know certain things to be able to do certain concepts. You just need to be aware of them. But obviously, there is still a heavy problem solving aspect. Like, it's not like they're just gonna tell you what to apply. You're gonna have to, from all of what you know, you're gonna have to figure out what the question is asking and what you need to do to get the answer, obviously. So I guess you could say it's not all just pure problem solving, but obviously there's still plenty of that.
Got it.
Got it.
Thank
Yeah,
you.
I wouldn't say you can just memorize everything and it'll be okay.
That makes sense because I think from a lot of the parent standpoints was they weren't sure how that test would be. And yeah, that makes a lot more sense if it's part, half is memorization, the other half is
Yeah.
the application of the
And
material.
again, like if you're unsure, they do have just all of the past exams from like decades that are just posted on their website. So if you're unclear, you can just go and look through those, and then those are literally the exams that they put out in previous years.
Very cool.
So I would definitely encourage anyone who's interested to have a look at those and even obviously take them when you're ready.
Yeah, definitely. And I'm so glad that, these resources are now available online. It's really a privilege to be growing up in the digital age where we can have all of our answers just at our fingertips and what we want to study at our fingertips too. Um, well, I mean, I think this is about it for the questions that I've seen in the chat. Miss Lee, did you have any other questions?
Sorry, I do have another one. I promise this is the last one. So I know for the Olympiad physical, for the even for the AP physics, I think they have a pre-request for you have to know the calculus and pre-calculus, something like that, and math. For chemistry, does the kids need to have those math, skills before they jump into AP chemistry and the Olympiad competition?
For AP chemistry, I'd say that that you don't really there's not really strict math prerequisites. So long as you can do algebra, you'll be fine for the AP exam.
Okay.
But if we're talking about the USNCO, then the prerequisites get a bit more complex. For most of the maths on the USNCO, actually, it's about the same as the AP exam. Maybe I'd suggest maybe pre-calculus because you're going to be dealing with a lot of logarithms, exponentials. Also, for the USNCO, it's a very good idea to get at least some hold of a calculus, particularly integration and a bit of integration differentiation.
Mhm.
It's not strictly necessary. It's just just comes in very useful when you want to say when you have a formula and you want to derive it, for example. It helps a lot with memory. It helps a lot with remembering the formulas, but it's not strictly necessary.
Yeah, calculus is really in chemistry at least for these. It's useful more to kind of understand how the formulas work, not necessarily needed to answer the questions if
Okay.
you would rather just memorize them.
I see. Thank you.
But
Thank
definitely
you.
pre-calculus is good to have.
I see. Still need a lot of applications to do the chemistry, but it's not heavily on the theory part, right? But from what I heard from my physics teachers, they complain the kids didn't really have the prerequisite knowledge, so it's very hard for them to learn the AP physics. So sounds like chemistry is a little bit better, but again, I believe as far as you want to be on top of it, you still have to be, get yourself ready for the, for the math part. And even like you said, for the algorithm, for the logic thinking, because you do need the problem solving as well. So I think no matter what you learn, I guess from what I got from, you three's conversation, I think is, no matter what area you want to success, you got to hard work and figure out, you got to really, have a passion on it. I really, really appreciate, the sharing that you guys have. I learned a lot from you, both of you. Thank you.
No problem.
It was a pleasure speaking with you.
Thank you so much for joining us today, guys.
Yeah,
Presenting to all
Thank you
these
too.
students. This is fantastic. Great job.
appreciate everyone's here. Specifically for all of you that are still here, and especially our younger students, is just be curious, right? There are so many things in this world that we can learn from and learn about. being curious about everything is the most important. Having that desire to learn more, which I know I see a couple names here tonight. I'm not gonna uh, name drop you guys, but thank you those that are here to really be willing to always ask questions, always wanting to do better, always wanting to learn more. That's the mentality that you have to have if you want to be successful, and if you really want to, spearhead some change, discover something new, change the lives of, everybody here on this planet. I'm sure one of us, maybe even Ian or Dylan, will be the one to spearhead some new change that we have, either in what, Ian, are you thinking renewable, something in renewable energy,
We'll
or
see. I'm not too sure yet, but hopefully there'll be something.
yeah, I'm so excited to see where you guys end up. And then Dylan, of course, I know all about your passion for chemistry. And seeing you this summer, working with you this summer has been a pleasure, and I can't wait to just, have more time to follow both of your careers and have our students learn more from the two of you. Well, thank you so much, everyone, and I really appreciate everybody's time tonight. And then for those that are interested, please contact Brian or I or Miss Lee if you're interested in learning more about the chemistry program that we are piloting this fall. Okay, well, good night, everyone, and we will see you very soon, hopefully.
All right.
Yeah.
Bye bye, everyone. Thank
Well,
you.
have a good night. Hopefully, yeah. Hopefully, I'll see some of you in the
Yeah.
class.
Have a
Bye
good
bye
night,
bye
everyone.
bye.
Thank you so much, everyone, for joining us. Have a great night. Bye.